is the fourth example that we have preloaded, the fourth tutorial example we have in OpenBDLM, where we're going to see how to use non-harmonic or how to model non-harmonic periodic patterns. So we're going to define that in a minute. So first step, as usual, start OpenBDLM main. So we want to use the interactive tool to load new data. So we're going to choose 0 for the interactive tool. We have to enter the project name. So here we're going to name it example traffic. So here, example traffic. Okay, enter. Do we want to generate synthetic data? No, this is not the goal here. So what we want to do is to build a new database. So option 0 to load new data. So our data is already contained in data, CSV, example traffic. We have a single time series. We add it here. I'm done. So perfect. We see that here we have traffic data for the first part and we have missing data to the end. So this is a common way we can use if you want to forecast on the long term to see what will BDLM forecast. You add timestamps at the end of your time series, but you provide NaN values. So what is it going to do is automatically OpenBDLM is going to fill the blanks where you have NaNs with the prediction from its internal model. Okay, we can close this one. The timestamp here is roughly 30 minutes for all your time steps. So this is your reference time step. What you can see here is the raw data. So we can see this is traffic. So what we have here, the low peaks are the weekends, the high peak are the weekdays. So we can see that we have a daily pattern as well as weekly patterns overlaid on it. So in this case, that wouldn't be a good candidate to use the component 31, which represent sign-like component. So here, that's why we have a new component we can use to do this. So in this case, no more pre-processing is required. So we can choose option 7, save and continue. So option 7, okay, the same plots appear again. I can close these ones. How many model classes we want, in case we want a single model classes. And now, instead of using the component to model the periodic phenomenon 31, which is periodic, we want kernel regression, which allows to model non-harmonic periodic phenomena. So for this, our model is going to be 11, 51 to use the kernel regression, and 41, which is again our residual component. So type return, perfect, the model is loaded. So now we have to do a special thing, because we have to specify for that kernel regression what is the period we're seeking to model. In our case, remember, this is the weekly pattern expressed by the traffic. So we're going to choose the option 11 to access the parameter of our model. So here we can see we have the parameter number 3, which by default has a value of 365.24. This is a period. We want to use option 1 to modify this parameter value. So parameter number 3 that we want to modify, the new value is going to be 7, because this is the period expressed in days. Here we want to model the weekly traffic behavior, so we choose a period of 7. So the new bounds we want to have for this parameter, here we choose NaN and NaN, because this parameter doesn't have to be optimized. So by providing NaN, that prevents the parameter from being optimized. Perfect. So now what we're going to do is that we're going to modify the training period to restrict it. So we're going to choose the option 13 to modify the training period, option 1 to modify the training period. Usually it takes by default the entirety of the data. Now we're going to restrict this, or we're going to start from day 1 and restrict it to use only 2 weeks to learn the parameters. So how many days is this? 14 days. So return, perfect. Now I'm at a step where I can learn my parameter value. I'm going to choose step 1. So I'm going to use Newton-Raphson, select 1. So now it's going to start the optimization process. Again, the goal is what? Modify my parameter value that are represented here in order to maximize that log likelihood. Keep in mind that process might take several minutes. If you want to skip it, we have the configuration file is already preloaded in the configuration file folder you're going to find here with traffic optim that you can see here. So if we want to stop the process and directly reload the optimized configuration file, I can kill the analysis here. I'm going to directly use the optimized file here. I'm going to copy the name here. I'm going to restart OpenBDLM. Perfect. And I'm going to directly say between quotes, I want you to load this configuration file. I type return, and automatically it's going to load the model. Okay. And now what I can do is that since the parameters were already optimized, the initial hidden states were already computed, I'm ready to estimate my hidden states. So I can choose option 3 and choose option 3, and I can use the filtering step using the common filter. So option 1, and now OpenBDLM is calculating each of my hidden states. Okay, here you had a warning in the back saying that because the results are greater than the threshold, which is set by default at 100 megabytes, the results were not saved in memory. But this is not an error in terms of processing. This is just because the size of the result, in order to avoid generating very large file, were not saved. So what you can see here is the kernel regression component. So what it does here, and I'm just going to quit in order to have access to my figures. What you see here is for each of the week, how did my pattern look like? This is a pattern that was learned by the kernel regression. So this is the prediction from the kernel regression pattern that were overlaid week by week. What you see here is each of the underlying hidden state variable that is estimated with BDLM using the kernel regression pattern. So you see these are the values of each of my hidden state used in OpenBDLM. Then what you have here is my autoregressive component, which represent what cannot be explained by the other component in OpenBDLM. Then what I have here is the values for my hidden state variable representing my kernel regression. So what you can see here, the little step, we can see that every time it's a step, it's because that hidden state variable has been activated in the kernel regression component and is slightly estimated by the current observation it's seeing. And what you can see here is the kernel regression component that is really able to capture the non-harmonic, so non-sine-like periodic behavior that is present in such a traffic data. So we can close it, and we can see that the baseline here, since we're using filtering, our initial uncertainty about the baseline is relatively large, and then the more data we accumulate, the more this gets refined. So what you have here is in black the expected value, in green this is the plus or minus 1 standard deviation for our estimated hidden states. And globally, this is the predicted displacement. And what you can see on the right here, remember, at the end we had a lot of nans, so we don't have any data at the end here. The only thing we have for the last 2 weeks are the forecasts that are returned by OpenBDLM. Because what? Remember, we had missing data. So here we have data, so we see the estimation is very precise. We have estimations that are slightly less precise here. Why? Because it's in full forecast mode for the last 2 weeks. But we can see that the pattern that we can observe here closely match what we observe for the preceding weeks. So we can see that even if we have complex patterns in our state, using the kernel regression component, we can learn such complex patterns. So again, if you want to export these results to either and modify it or look at it, what you can use is option 17. So if we go back in OpenBDLM, we go to our traffic opsin 7. If we want the option 17, export 1 in config file, what we're going to get is this config file here, where we can and modify either the parameter value, initial value, or some of the option used to define what we want for our analysis.